So the third thing I'm going to show you is the quality of the drawings, how important that is. Now, I say it's important, but I think it's going to be a thing of the past because really drawings are not all that intuitive. So, okay, they look nice, but what do they actually do? All they do is feed the brain. They don't feed the computer. So they're a way for humans to look at the river. So this is the bridge at Shipston, and as you can see, there's a lot of information on there, and we've got the road levels there, we've got the parapet, we've got the arches, we've got all the soffit levels of each arch, the Springer levels, that's what they're called, and we've got this huge box of numbers below. So this gives us the chainage, which is the distance across the section, and the hard bed level above ordnance datum for each of those points. And you notice all these are what are called cranked, because if we try to put all this information below this below each line here, it would just, we wouldn't be able to read it. So these are cranked, and this is done automatically within our software, so it comes out all nice and neat like that. So lots of drawings go out. We have to produce these, but they have title blocks on. They look great, but like I say, they're kind of dumb really. People are taking information off these and putting them in their superior software, which actually does something with that information, which is what I'm going to get onto next. So number 4 is model data. Now this is the data with intelligence. This is the stuff that goes to work for you. This is the stuff which automates a lot of the manual stuff that our engineers that we pass this information on to have to manually type in. I'll show you an example here. So if we look at go down to Halford and look at those flood tunnels which featured on one of my earlier videos, we can see here very similar to what you'd expect in a CAD drawing, but what we've actually done with this, we've overlaid information onto this which enhances the data that goes into the model. So for instance, we have a conveyance estimation system which is basically the roughness of the ground along here, and it's brush and it's soil. So every one of these points here will take that form. So that every single one of those points in the model file will have that information attached to it. If it changed here, we could put something else, and if it changed there, we could put something else, and everything in between the points would assume the one the marker to the right of it. So there's a bit of extra information that goes across, and that can actually convert to a Manning's End value, which helps the modeler set those when they're setting up the model. Structures. So every single one of these arches has got a heavier line around it, and that is what the surveyor has defined as the opening of that structure. Now most modelers, and again with the parapet there, that is defined separately. So a modeler would ordinarily have to look at the CAD drawing and type all this information in to get to the results that we're going to provide, just like that, and I'll show you. Export flood modeler. If we pick the overflow structures, all that information has come through. It's created all the units, and it's also created all these flood tunnels exactly as they're represented on site. So the modeler doesn't have to anymore get this ground information and then put this information in on top. It will come through directly. So number 5 of the most essential things of the river survey is, of course, quality assurance. So all our clients at the end of a job will get a checklist that says mostly yes all the way down. This is something that we go through at the end of the job, but all throughout the job we are doing quality assurance at every stage. It's a bit like one of those things, if you let it go too early, errors then creep up throughout the whole project and you end up with a ball of knitting. So we tend to check stuff as we go. Control is really important, how we're deriving the heights of all these points that we're taking. So we record checks, daily checks on the kit, and we can get a standard deviation, so over 246 measurements there over 6 different days, or different satellite windows if you like. We had a 17mm deviation. That's typically what we would expect with the equipment that we're using for GNSS. And here's another one here where we've got 11mm over a few more readings. So all these kind of quality assurance things that we do along the way are really important. Here's another one that we would do. This is the River Stour. This hasn't been QA'd yet, but if we look here, this is a long section. So this is the river looking on its side from Mitford Bridge all the way down to Halford. And if we look at this, what we'll do in the QA is we'll look at the water level here to make sure it's sensible and it's flowing downhill. If we see a spike or a rise in this, then there could be a problem with that particular cross section. So there are one or two on here I did notice earlier which will need investigating. So there's one there, look. We didn't get any significant rain. Sometimes you get a rise in water when you have rain from one day to the next. Sometimes it might be tidal when it's up and down like a yo-yo, but in this case that will need investigating. It's more likely to be this point here that's low, so that will be looked at. So all in all, the QA is done throughout, but it is one of the last things we do before we deliver the project to our client. And you know, when you look at the whole project, you look at the videos, you've kind of seen it from start to finish, battling through that undergrowth, struggling with the boat through hot temperatures across difficult sort of blockages in the river, getting around all the landowners, using really expensive equipment to do really rugged work, then bringing all that data in, thousands and thousands of points, hundreds and thousands actually of photographs, bringing it all together and delivering it. That's how we do it, guys. That's what we love doing, and we do it to reduce flooding, and that's our mission. And I hope you've enjoyed these videos, and I hope to do some more on some more projects soon. Thanks for listening.